These types of questions are quite common in your prelims, which is coming up, and your O levels, so it's best to know how to solve them. So the first part of the question will always look very innocent. It's just asking you to differentiate something. So let's just do it as it is. So looking at this function, we know that we need to use the product rule in order to differentiate this because there are two things multiplied together. So I'm going to copy down this to show that I am answering the question. So first, we need to differentiate x plus 3 multiplied by ln of x plus 3. So let's go back to basics. If we differentiate x plus 3 bracket, what we are doing is actually what we can do is we can split the differential on the inside. So this means that we're actually differentiating x plus, and then we're going to differentiate 3. Differentiate x is just 1 by the power rule. And then if we differentiate a constant, it's just going to be 0. So it's just going to be 1. Which means that differentiate this multiplied by this, it's just going to be ln of x plus 3. Then next, we need to have x plus 3 multiplied by the derivative of ln of x plus 3. So this is 1 over, let's not go there yet. We have x plus 3, and then if we want to recap again our basics of differentiation, if we differentiate ln of f of x is just a function of x, can be 2x, x squared, e to the power of x, anything related to x. If we differentiate this, it's going to be 1 over f of x, so you just copy down here, times f prime of x. So we differentiate the f of x. Actually, this is just your chain rule, but this is a specific example to use when dealing with ln. So this, and we multiply, and we already know that if we differentiate the inside, which is x plus 3, we will just get a 1. So we will get 1 over f of x. F of x is x plus 3. So we get 1 over x plus 3. And you realize this and this will actually cancel out because they're the same. So we can cancel them out, and you're left with 1. So our final answer for this is ln of x plus 3 plus 1. And we're done. So this question doesn't really take that much time because it's straightforward differentiation. So now the second part is the one that most students struggle with, and I'll go to it now. Okay, now this question is a bit more complicated because it says, hence find the integral of ln of x plus 3 dx. Now you see, first of all, that the question uses the keyword hence. So you need to use your answer from part 1, which is in green, and also you realize this is worth 3 marks. The previous question was only worth 2 marks. So there's more at stake here. So we immediately see a problem. We cannot integrate ln of x so directly because we don't even know what the integral of ln x is, because remember, this is O level. So what do? Well, we have to go back to basics. If we want to solve this type of question, we need to go back to basics. What do I mean? Well, the first thing that you are taught when you are taught integration is that integration and differentiation, they are the reverse of each other. If I were to quote the textbook, it says this: if d dx of small letter f of x give you capital f of x, this means that the integral of capital F of x dx gives you small letter fx plus c. So basically what I'm saying is, if I differentiate something and I get back something, and if I intake that and I integrate that something, I will get back the original function. So using this information, how can I solve this? Well, what I like to do always, and what my teacher likes to do, is I like to just state the obvious. What do I mean? I differentiated this to get back this. So by what I just said just now, if I integrate this, wouldn't I get back the original function? I would. So what I'm going to do is I'm going to just write that out. So integral of ln of x plus 3 plus 1 dx equals to x plus 3, then we have ln of x plus 3, but we add a c1. The reason why I add c1 is because we need to split up the integral later So you can write C1, or if you don't, you can just write C. But one important thing is, when you integrate stuff and there's multiple plus C, do not put plus C plus C plus C, because plus C is meant to say add a constant. So if you have, let's say, integrate whatever, then plus 3x plus C equals to whatever plus C, these two are adding the same constant. But for all you know, they may be two different constants. So never put plus C plus C. You can do like C1, C2, or if you want to be more clear, put C and then maybe put a D here. So whenever you're addressing constants in integration, don't use the same constant. So back to our question. I put C1 here, so I'll put a C2 there. So let's analyze this. We want to get only integral of ln of x plus 3, but in the left hand side we have ln of x plus 3 plus 1. So again, let's go back to our basis of integration. If we have integral of fx plus gx dx, where f of x and g of x are two functions of x, meaning is anything related to x, then we can actually split up the integral into the two parts. So then that means you can integrate them separately. Same with differentiation. So if we apply that here, we can see that there is this plus 1. This plus 1 is actually a function of x, because think of a function as like a graph where f of x is a y. So when I have y equals to ln of x plus 3, this is a function. Y equals to 1 is also a function. It's just that the line is a straight line. And there won't be many use of y equals to 1, because it just means that you just output a 1. So we can split this up. So I'm going to maintain my integral of ln of x plus 3, because we want to find that. Integral of ln x plus 3 dx, and then if we integrate 1, we get an x. But that's not all, we have to add a plus c. But since we already have a plus c1, I have to add a plus c2. Then I just equal and I copy what is here. x plus 3 ln of x plus 3 plus c1. So in order for me to get the answer, all I need to do now is I just need to shift both of these over to this side. So my final answer will be integral of ln of x plus 3 dx equals to x plus 3 ln of x plus 3. Then we bring this here, it's going to become a minus x, and c1 minus c2, a constant minus another constant is still a constant. So I'm just going to add a simple plus c, and we are done. So let's review. This type of question, where they will first ask you to differentiate something, just differentiate normally. Then they will say, hence find integral of something. Usually this something is something that you cannot integrate normally, because you may not know how to, because sometimes they might ask you to integrate like they ask you to integrate like sine x, cosine x, something that you cannot split apart easily. So from there, what you need to do is, from your previous answer, which you differentiated, integrate your answer and you get back the original function that they asked you to differentiate. This works because of the principle of integration, where it is the reverse of differentiation. So you just write that down, and then what you want to do is you want to manipulate your integral into what you want. So in this case, because I don't want the plus 1, so I integrate that, because I know how to integrate 1, it is just x. Then I move everything that I don't want over to the other side, and I finally solve for whatever integral that I want. So yes, this is how you can get 3 marks. Honestly, I feel like this question is not too difficult, because it just requires a little bit of thinking on how to manipulate this. But if you want a challenge, then I will present this integral to you. There is no step 1. I will present this integral to you that I actually found on another person's TikTok, which I will link, and the person actually go through the solution. I will link it in the description below, as well as maybe in the next video I'll go through the solution to this. If you want a challenge, find, without any help, like there is no part 1, the integral of secant squared x times e to the power of tangent x dx. This is only for those who want a challenge. Obviously, this is the O-level syllabus. If this is the A-level syllabus, then it will be extremely easy. But yes, try this out. If you understand this already, this is an extra challenge. Try this out. And with that, I'll see you guys in the next video. Bye bye.